Hello everyone, my name is Kim Jun-hyuk and my major is the Mechanical Systems Engineering. I will make presentation project on making autonomous driving system. Here's the agenda for today's presentation. First, I will provide the project background, then introduce the system architecture, followed by the core logic, the problem-solving process, and finally conclude with some reflections on the project. This project started in the My Car Club when we recognized launching of autonomous driving department, decided to challenge at that contest. Our mission was to create a vehicle capable of navigating autonomously between Robocons. As a result, we did the autonomous driving successfully and received the Encouragement Award in the Autonomous Driving Performance Department. Now, I'll explain our autonomous vehicle system. The system consists of three main components: the steering module, braking module, and electronic circuit configuration. The steering was controlled by using a rotary motor and variable resistor. Also, the braking system was controlled by using a linear motor and wires. All of these systems are controlled via Arduino to enable autonomous driving. The mission was to make an autonomous driving system capable of navigating through Robocons. This required building both the autonomous car and driving logic. I used RS Melodic on Ubuntu to process sensor data and transmit control signal to Arduino. After then, Arduino transmit the signal or register value to a vehicle. The sequence I followed is based on the perception, judgment, and control cycle. It is the fundamental to making any autonomous driving system. One of the key technologies was object detection by using YOLO V5. This algorithm is based on machine learning for object detection. We make the optimized model of camera perception so the system is even capable of performing at night with high accuracy. On the right side, you can see the implementation of the self-developed vision logic. I'll tell you about how to drive at straight course. There are three modes in our camera logic. The first one is driving mode. In the driving mode, the system detects cones using YOLO V5. In this mode, we used the Rensak algorithm to connect the bounding box coordinates of cones detected by their color. The intersection of these lines provides a vanishing point, which is used for steering. However, relying solely on the vanishing point isn't enough for driving along the center line. So I also use the angle between the two lines as an additional parameter for the more accurate steering. When the vehicle approaches a stop zone, the number of detected cones decreases. This situation makes the unstable vanishing point. To maintain stability, I incorporate the tendency of existing lines into the stop zone lines. This process assists generating more stable vanishing point by creating additional brown and green lines which include the tendency of previous frame. When the system detects only red cones, the vehicle switches to stop mode. At this process, a polygon is created using the coordinates of the red cones. The center of this polygon is calculated and used to steer the vehicle until stop at the stop line. This method allows the vehicle to stop with precision and safety. For curved driving, I use GPS data to convert coordinates to UTM format and follow predefined waypoints. The heading angle is calculated using IMU data and to navigate on global map. I implemented the Stanley method in code. This method helps correct the vehicle's heading angle and minimizes cross-track error. It ensures the vehicle following the desired path accurately. One of the challenges I faced was integrating the outslider with the camera for sensor fusion. Due to compatibility issues with open source software, I had to turn to the PCL for point cloud pre-processing and clustering. Another issue I confront was that the LiDAR didn't detect the rubber cones. So we focused to the camera and GPS for driving while using a LiDAR mainly for a collision avoidance. Sometimes the vanishing point was splattered because of the background, for example, sky or greenery. So, to resolve this problem, I applied the Renzak algorithm. It helps ignoring outliers and focusing on the underlying tendency, so we can get the stable vanishing point. This is the schematic of the autonomous system. These sensors make the perception data, and based on that we make the decision of maneuver. After that, we control the vehicle by using ROS system and Arduino. This is the feedback of this project. First, if we use the Simulink fluently, then we could monitor the accuracy of control. Second, if we succeed LiDAR and camera fusion, then we could make the local mapping. Third, if we can get exact speed, we could steer more stable. If I have a next opportunity, I want to try and execute that things. Thank you for your time and attention.